Assalamu alaikum to class. Today our topic of discussion is the wing venation modifications. बेसिकली मैंने आपको जो एक विंग वेनेशन का जनरल पैटर्न था वो पढ़ा दिया था. अब इसको फर्दर हमने आगे लेके चलना है. इंक्रीज्ड विंग, ये यू कैन सी दिस इंक्रीज्ड विंग इन द लेपिडोप्टरा, and the members of the lepidoptera are the moths and the butterfly. They have extended wings. All right, and next is the reduced wing venation. This can be visible in the thrips, and they are the members of the order Thysonoptera. Here you can see that their wings are not broad; they are just like the bristle. When their surface area is reduced automatically, they have less wing venation. Increased wing venation, here you can see that number of cells are increased from the basic pattern. This is the elytra. Elytra are the hard wings used for the purpose of the protection, and these are the characteristic in most of the beetles. Actually, this is a characteristic of the beetle. Four wings are modified into elytra, and these are the hind wings. These are membranous structures. This is the wing of the fly and the dragonfly. Here you can see that various veins are present: cubitus, costa, subcosta, radial plus median, arcutus, nodus. Nodus is the area where the second major vein contacts or meets with the anterior region. It meets with the terminal ends of wing. Here you can see different wing venation. This is a further description of wing venation of each insect, fly and the dragonfly. Next is a cockroach wing. I already taught you four wing of cockroach are known as the tagmin or tagmina, and they are less sclerotized, used in flight for as well as in the protection of membranous wing too. This is the cockroach. Here you can see the veins. This is the anal vein. This is the cubital posterior vein, cubital anterior vein. This is the medial vein, and this is costa, this is subcosta, this is the radial vein. Cockroach is very common in our houses, so all of you are familiar with the cockroaches. This is a further description of the veins in its wings. Next is the grasshopper wing. Grasshopper four wings. They are tough, just like woody. You can say, and they have appearance like the wood. Tough, opaque, tagmina, narrow, and covering of the hind wings and abdomen at the rest. Hind wings are broad, membranous, and folded in a fan-like manner. Here you can see the wing of the grasshopper, various veins. You have to cram the name of these veins in each insect. This is a further description of the veins. Stick insects wing. Stick insects are just like they're very slim, or you can say they're slender, and they have very long length. Their forewings are tough, opaque, tagmina short and covering only the base part of the hind wing. At the rest, hind wings from the costa to cubitus are the tough and opaque like the forewings. The large anal areas are membranous, and folded in a fan-like manner. There are no or very few branching in the stick insect wing veins. Here you can see the wing of a children's stick insect. Various veins are clearly visible here. Next is the cicada wings. Both forewings and hindwings are membranous. Okay, see this wing and vein arrangements. This is a description of the various veins in the stick insect. Beetle wings. Beetle wings are functional wings of beetle are the hind wings. Anterior are modified into the elytra. These are the hard structures. They don't have any kind of venation. Here you can see the functional wing venation of beetles. Its wing venation is reduced and modified due to folding structures. Costa radius anterior, radius posterior, media posterior, cubitus anterior, anal vein. These are all veins present in it. Fly's wing. They have one pair of functional wing. The hind wings are reduced to the club-like structure known as the halters, and the halters vibrate during the flight and act as an organ of balance. These are the wings of the flies. Okay, you can see the veins. This is a description of the veins. Next is a butterfly wing. They have two pairs of wings clothed with the one or two layers of scales. Scales are present over their wings. Here you can see the wing venation in butterflies. Wing venation of Nymphalidae. Wing venation of Lacinidae. This is a description of veins in insects. Next is the Hymenoptera wing venation of the sawfly. Why these are known as the sawfly? Because they have saw-like ovipositor used for the boring. Here you can see the pterostigma. It is present in the anterior region of the wing. It is darkly stained cell. Here you can see the wing venation of the wasp. All of you are familiar with this naughty creature. This is the wing venation of the ant. This is the description of the wing venation of ant. Here you can see wing venation in horodonta. Okay, this is the completion of the topic. Thank you.